So these are few stream data, that is the data extraction: 220 to 60, 270 to 160, 52 to 10, 160 to 210. So I told you there is a supply temperature, there is a target temperature. One is the supply temperature, one is the target temperature. That is a two cold and two hot stream. Here it is same. There are two hot streams are there, 220 to 60. Have a look, 220 to 60 at the reboiler section. Have a look here. You will get it 220 to 60. Then that is higher to lower for a hot stream. Then again, second hot stream is 270 to 160. Here it is 270 to 160. So in if you go in industry or somebody give it to you the temperature conditions or stream data, you can easily calculate or modify the flow sheet accordingly. But you must have the CP value or heat duty at least. You must have that. So here there is a CP value is given. So how you calculate this heat duty? By use of MCP delta T. Okay. So once you have the heat duty, you can easily calculate CP. But if you have CP, you can easily calculate heat duty. Okay, there is a formula for that. Q is equals to MCP delta T. You already studied in heat transfer. So these are few examples for data extraction. There is a one. You can tell me that there is a one cold stream is there, 20 to 200 degrees Celsius, and one hot stream, 150 to 50 degrees Celsius. So that is one cold stream and one hot stream. Then again, another another flow sheet is there. You can compute the data extraction, and there is a supply temperature. So you have to define first the data extraction. If I can give it to you the flow sheet, you have to define first how much streams are there, how much cold, how much hot. So what is given conditions are there, either in terms of specific heat or delta H value. So here it is 20 to 200 degrees Celsius. That is your one cold stream, and 150 to 50 degrees Celsius. Okay. So these are few discussion about the codes data extraction. You must read that because there is a time constraint. I just told you the how you apply the concept, how you define or how you construct the data extraction. Okay, there are few guidelines for data extractions. These are that at the last you will get it, summary guidelines. These are some guidelines for data extraction as well as heat exchange phenomena. So keep your hot stream hot and your cold stream cold. These are few guidelines. Once you solve the problem of pinch analysis, so you must keep these guidelines with you. Avoid over specifying the problem. Don't break up stream unnecessarily. Avoid non-isothermal mixing at the energy targeting phase. Then check and define data in the neighborhood of the pinch. Then identify any possible process constraints and find targets with and without them to see what energy penalty they impose. Only essential constraints are included in the stream data. Stream data should be linearized on the safe side. On the safe side, mixing should take place isothermally. Utilities should not be extracted with stream data. Data should be extracted at effective temperature. Then 11 point is soft constraint should make use of the plus minus principle to improve the targets. Heat losses from cold stream can be accounted for by the addition of fictitious cold stream, which should be included in analysis. Heat loss from hot stream can be counted for by splitting the hot stream to signify loss and should left out of analysis. Accurate data are not always required throughout the whole problem. Enforced matches can be counted for by leaving parts of the stream data out of the problem. Once you solve the pinch analysis, so you will get it these all guidelines. Because these guidelines I will discuss with you earlier. Okay, once you solve the problem, you will get it where you have to pass the heat, where you have to take the coldness, or